Okay, so here we're going to be talking about factoring out the greatest common factor. Okay, so let me just start with the example that's at the top here, and then we'll try some on our own. All right, so the example wants us to factor the greatest common factor from this expression right here. Okay, so step one, it says to look at the coefficients. So the coefficients are just the numbers in front of each term. So we have a 4, a negative 16. Don't even worry about positive and negative. A 4, a 16, an 8, and a 12. All right, so we want to say what is the greatest common factor of those numbers? What that means is what is the biggest number that divides evenly into all of these? So the biggest number that divides evenly to all of them is 4. Okay, next we want to, step 2, look at the variable. So we have an x to the 4th, x to the 3rd, x squared, and x. Now I just want to point out, like for example, x to the 4th means that you have 4 x's being multiplied together. So x times x times x times x. Okay, so for example, this term right here means we have 4 times and then x times x times x times x. Okay, so all of this is being multiplied together to give us 4x to the 4th. Okay, so anyway, back to step 2. Look at the variable. Can I factor out a variable from every term? And yes, we can. Since they all contain x's, we can factor out an x. Now, we can't factor out more than one x because this term only has one x. Okay, so you can't factor out more than a term has. So here we're going to factor out an x. Okay, so basically step 3, identify the greatest common factor. So the greatest common factor is 4x. Okay, so now I'm going to kind of talk about step 3 and step 4 together. So step 3 is to identify the greatest common factor, which we did, right, 4x. And in step 4, what we do with that 4x is we place it on the outside of a parenthesis. When you're factoring out the greatest common factor, you're just putting it on the outside of the parenthesis, and then you're writing what we're left with on the inside. Now, how we determine what we're left with on the inside is we just divide every term from the original expression by the greatest common factor. Okay, so this 4x is on the outside. That's our greatest common factor. So what you're really doing is you're taking this original expression and you're dividing it by 4x. So 4 divided by 4 is 1. And x to the 4th divided by x, you could think about it one of two ways. Okay, when you divide, I'm going to put a little exponent on this. 4x is the same as 4x to the first power, right? Oop, that was a little bit, but that says 4x to the first. So when you divide two terms with the same base, all you're doing is subtracting the exponents. 4 minus 1 is 3, so it gives us x to the 3rd. Okay? I mean, how I like to think about it, I'm going to erase this one. It was a little big. I like to think about it like this. If you started off with x to the 4th, right, 4 x's, and you took one of them out, don't you still have 3 x's? So we write that as x to the 3rd. Okay, and then just take this minus sign right here and bring it down. 16 divided by 4 is 4. X to the 3rd divided by x, okay, if we subtract the exponents, 3 minus 1 is 2. Or how I like to think about it is if you had 3 x's being multiplied together and you took one of them out, doesn't that leave you with 2 x's to put in here? Okay, and then right here, 8 divided by 4 is 2. We had 2 x's, we took one out, it leaves us with 1. And then 12 divided by 4 is 3. We had an x, and we took it out, so we don't have any more x's to put in there. So this is in factored form. Okay, so let's try some examples on our own. So on the bottom of the page, there are 6 of them. Okay, so I'm actually going to just do the odd examples with you, and then I'll have you try the even examples on your own. All right, so it just says to factor each expression by factoring out the greatest common factor. All right, so with number 1, we're going to first take a look at our numbers, right? We have a 9 and we have a 27. And we want to say, well, look back up at step 1. What is the biggest number that divides evenly into each of them? So 9. So I'm going to pull out a 9. Then I'm going to look at my x's. I have x to the 5th, which means we have 5 x's being multiplied together. And here I have x to the 3rd, which means I have 3 x's being multiplied together. So I'm going to pull out as many as I can, but I can't pull out more than, either one of the terms has. So I'm going to pull out x to the 3rd. Okay, I can't pull out more than that because this term only has 3 of them, and I want to pull out as many as I can. A rule of thumb, all you're really looking for is whichever has the smaller exponent. Okay, so now that's my greatest common factor. So in parentheses, I'm going to write what I'm left with. Now remember, when you factor out a greatest common factor, all you're really doing is just dividing. 9 divided by 9 is 1. If you want to put a 1 there, you can. But you don't have to if you have variables remaining, which we are going to have, right? X to the 5th divided by x to the 3rd would be x squared. Okay, you just subtract the exponents. Or you could say, if I had 5 x's and I pull 3 of them out, at least we have 2 to put here. Okay, now let's take the minus sign and bring it down. 27 divided by 9 is 3. And x to the 3rd divided by x to the 3rd is 1. And 3 times 1 is just 3, so I'm going to leave that as a 3. Or you could think about it, I had 3 x's, and I pulled 3 of them out, so I don't have any more left to put here, so I'm just going to close up my parentheses. And that is my answer. Okay, number 3. So we're going to do the same thing. We're first going to look at our numbers. We have a 14, a 21, and a 7. All right, so the biggest number that divides evenly into them would be 7. And here I have a to the 3rd, a squared, and a to the 1st. So I'm looking for which one has the smallest exponent, which would be a to the 1st. Okay, I can't pull out any more a's than each term has, and this only has 1. So I'm going to pull out just an a, which means a to the 1st. Okay, and then in parentheses, I'm going to write what I'm left with. Now remember, when you're factoring out the greatest common factor, you're actually dividing by this right here. Okay, so 14 divided by 7 is 2. And a to the 3rd divided by a to the 1st would be a squared. Okay, you could either subtract the exponents. 3 minus 1 is 2. Or if you had 3 a's and you took 1 out, you still have 2 left. All right, let me bring down the plus sign and just keep going. 21 divided by 7 is 3. And then I had 2 a's and I took 1 out, so I still have 1 left to put next to that 3. And then bring down the minus sign. All right, now 7 divided by 7 is 1. And a lot of times you don't have to put the 1, but in this case you do, because we had an a and we took it out. So you have to have something here, right? If you start off with 3 terms, you have to have 3 terms left in your parenthesis. You can't just close that up and just have a minus sign hanging out by itself, right? Or even worse, you can't just close it up here and then only go from 3 terms to 2 terms, okay? Since 7a divided by 7a, right? Anything divided by itself is 1, we're going to put a 1 there. And it makes sense because if you wanted to check your answer, you could always distribute back into the parentheses and see if it leaves us with the original expression. So 7a times 2a squared would be 14a to the 3rd, which is what it says here. 7a times 3a would be 21a squared, which is what it says here. And then 7a times negative 1 is negative 7a. Okay, so that checks out. Okay, now when you look at number 5 looks a little different. And, I bet when you look at this, a lot of you are tempted to, well, let's distribute into the parentheses, right, and combine our like terms and see what we could do with that. But they're not looking for us to do that here. It just says to factor each expression by factoring out the greatest common factor. So what we're going to do is we're going to look at each term of this expression, right? Like in number 3, here was our first term, here was our second term, here was our third term, right? They're separated by addition and subtraction. Well, if you look in number 5, this whole thing is our first term, and this whole thing is our second term, right? It's separated by subtraction. So look at the first term and look at the second term. What do they have in common? What could we pull out of both of those 2 terms? As you can see, look, they both have an x plus 4. That's what they have in common. So that's going to be our greatest common factor. We're going to pull the x plus 4 out of this first term and the x plus 4 out of the second term, okay? So let's pull out our greatest common factor, x plus 4. Now, I am going to have to group this in a parenthesis because I want to factor the whole thing out and put what I'm left with in parentheses, right? Just like we put here what we were left with in parentheses, or right here, what we were left with in parentheses. Okay, so if I take out of this first term, if I take the x plus 4 and take it out, don't I still have that 2x that I'm left with? So I'm going to put that in the first spot in my, remaining parenthesis. Then I'm going to take this subtraction sign and bring it down. And now let's look at the last term. If I took out of this term right here, the x plus 4, and pulled it out, factored it out, don't I still have this 3 hanging out? So I'm going to take the 3 and bring it down. Okay, and this is factored for us.